One more topic for this chapter is catalysts. Catalyst is defined as a substance that affects the rate of a reaction without being consumed. So it will speed up or slow down a reaction but will not be used up itself. They work by providing an alternate mechanism for the reaction, and that alternate mechanism has a lower activation energy. They are often consumed in an early mechanism step and then made in a later step. An example is the reaction of ozone to make oxygen. It's very slow without a catalyst, but if there are halogens, specifically chlorine, in the atmosphere, it speeds up the reaction significantly by providing an alternate pathway where we're making this intermediate and then using it up in a second step. So you can see here the energy profile. Normally you would have this high energy barrier with a transition state. A catalyst presents an alternate mechanism with lower transition states, lower activation barriers, and allows the reaction to proceed faster. We have some terms for catalysts. Homogeneous catalysts are in the same phase as the reactant particles. So the example we just looked at is a homogeneous catalyst. A heterogeneous catalyst is in a different phase. An example there is the catalytic converter in your car's exhaust system. It basically allows for these more dangerous molecules to adhere to a surface and react with each other, and then give off less dangerous gases. Here's the same picture, or same idea. A homogeneous catalyst is in the same phase. Heterogeneous catalyst is in a different phase. Here's how heterogeneous catalysts can work. So for instance, the reaction of hydrogen with ethene to break that double bond and add hydrogen across it. If you have a heterogeneous catalyst like platinum, it can adsorb to the surface, and that takes away a dimension of movement, and so it allows for the bond to break and then the molecule deabsorbs. There are biological catalysts called enzymes. Many molecules that are needed in a cell are large and complex, and so they need a catalyst to proceed at a reasonable rate. So an enzyme is something that does that, and they often work by positioning substrates in such a way that the chemistry can occur. It will orient it and take away a lot of that collision portion of the equation. The way it works, so you can see you have a substrate here that has a certain profile, and the active site has a very similar profile. It'll form a complex and then stress part of the molecule in some way so that the products release. Here's another picture, the enzymatic hydrolysis of sucrose. So you have sucrose, a molecule of fructose and glucose bound together, and when it binds into sucrase, which is the enzyme that breaks apart sucrose, it basically bends that, strains and weakens it, and so it breaks, and you can add water across it, and then you get the two separate parts.